Hello students, in this lecture we are going to discuss about the perspective views. So we are going to have total 3 videos for the perspective views. In the first video we will be discussing the basic terminology and the concepts related with the perspective views, and then in the later videos we will be discussing how to draw 1 point perspective and 2 point perspective views using AutoCAD. So let us start with the perspective views. So the perspective projections or the perspective views is just another way of representing the objects in a drawing. It is most commonly used as a creative art in architectural drawings or in technical sketching, but it is very rarely used in technical drawing. The basic difference between the perspective projections and the other type of projections which we have done so far in this course, like orthographic projection and isometric projection, the basic difference in the two is that in this case the objects are made in a more real way, having an element of realism in the drawing. For example, if you're looking at an object in real life, you're standing close to an object, the part of the object which is closer to you looks bigger in size as compared to that part of object which is far away from the observer. So that part of the object which is away from you appears smaller in size, relatively smaller in size, whereas the part of the object which is closer to the observer, that appears relatively bigger. So that kind of a realism uh, element is introduced in the perspective projection, and these kind of projections are primarily used for making architectural drawings and technical sketches. Now this slide shows a typical example of perspective projections. This slide shows a picture of a railway bogie. Now in this case we can see that the part of the bogie which is closer to the observer appears bigger. You can look at the windows or even the height of the bogie. The part of the bogie which is closer to the observer and the windows which are closer to the observer, they appear to be bigger in size as compared to the windows or the height which is away from the user, like at this end. Another example is that of a railway track. If you're standing somewhere here on the railway track, the width between the two tracks is relatively large. But if you look at the same track at some distance, then you can see that the distance between the two tracks is reducing gradually, and finally at one point you will see that the two tracks will ultimately merge with one another, and that point at which the two tracks appear to merge, that point is called the vanishing point. This slide shows typical difference between a parallel projection and a perspective projection. Now in this case we can see that all the three directions, the width, the height and the depth, the edges along all these three different directions of an object, they are parallel to each other. So the lines representing these edges are parallel to each other. Whereas in case of perspective projection, however, you can see in this case the horizontal lines, the width lines and the height lines, they are parallel to each other, but the edges representing the depth of the object, they are non-parallel to each other, and thus they appear to merge at one distant point, which in this case will be called as a vanishing point. So in this case the object is presented in such a way that out of three directions, one direction edges, they are appearing to merge at one point. So this is called as 1 point perspective projection system. Later we will also see different examples where you will see that even the edges along the width direction, that is horizontal direction, they are also not parallel to each other. So in that case those non-parallel edges will give rise to another vanishing point, so that will be called as 2 point perspective system. And later you will see another case in which even the vertical edges in case of a perspective projection are non-parallel to each other, so that will give you 3 point perspective projection system. So this property of the perspective projections gives the element of realism in the drawing. As you can see in this case, the height of the object, the height of this face, which is closer to the observer, appears to be larger as compared to height of this edge here at the rear face, which is far away from the observer. So this gives just an element of realism that the closer face is bigger in size as compared to the face which is away from the from the observer, that is smaller in size. This slide shows the comparison of an isometric drawing or a diametric or a trimetric drawing vis-a-vis a perspective drawing. Now in this case you can see whether it is isometric or diametric or trimetric drawing, the edges along the three directions, that is the width, the height and the depth, the edges along all these three directions are parallel in all these three cases. Whereas in case of perspective projection, in this case you can see though the vertical edges are parallel to each other, these edges will never meet at any point, but the edges along, say, the depth direction, the edges along the width direction, they are non-parallel, and when projected these edges will meet somewhere on this side at this point, which is called as RVP, that is the right vanishing point, and these edges when extended will meet at this point, which is called as the LVP, that is the left vanishing point. Now let us start with the main elements that are used in perspective drawing system. Before we go any further, I just want to highlight this, that the terminology that we learned in the chapter on orthographic projections, like we learned about different types of projection planes, the three elements, the observer, object and plane, and we also learned there that observer is assumed to be standing at infinite distance and the rays of light, the projectors, they are parallel to each other. So all those fundamentals that we learned in the orthographic projection chapter, they need to be kept aside while we are doing the perspective system. As has already been discussed in the previous slides, that the parallel projection system and perspective projection systems, they are quite different from each other. So please don't confuse whatever terms we are going to use in this chapter with the terms that we used earlier in the orthographic topic. So there are four main elements that are listed on the slide. There is an observer in this case, like the observer we had even in case of orthographic projections. There is an observer in perspective as well. There is an object. There is a plane of projection. Then there is a line of sight. Now this slide shows the arrangement of different elements when we are talking about the perspective projections. I would like to recommend that you should always keep this picture in mind while you are handling any problem on perspective projections. Now the key elements or the key terms that we'll be using in the perspective projection include there's a ground plane. This is just like a horizontal plane that we discussed in case of orthographic projections. So this is a ground plane, and there is an observer. The observer has a certain height. So the observer is standing on the ground. So the point where the observer is standing on the ground, that point is called as the station point. Now this is one important term that you should understand, because you will invariably be given some data about the station point in all the problems that you'll be doing. The next important thing is the height of the observer. So in this case, the height of the observer is the distance between the feet and the eye level. So that is the height of the observer. Then we just assume that there is another plane which is passing through the eye level of the observer. This plane is called as the horizontal plane. So you have a ground plane, you have a horizontal plane. The ground plane is a plane that passes through the feet level of the observer. The horizontal plane is a plane that passes through the eye level of the observer. Then there is a vertical plane which is called as picture plane. In this case, this is also very important term to be used. This is called the picture plane. Now this plane is a vertical plane, and this vertical plane actually meets the two horizontal planes, that is the ground plane as well as the horizontal plane. The line of intersection of this vertical plane with the ground is called the ground line. Similarly, the line of intersection of picture plane, the vertical plane, with the horizontal plane is called the horizon. So these are the important terms that one should keep in mind. There is a ground, there is a station point, there is an eye, there is a horizontal plane, there is a picture plane, and there is a horizon, there is a ground line, and the direction of viewing of the observer is called the vision axis, and wherever this direction of viewing of the observer meets the horizon, that point is called the center of vision, and later it will be also called as the vanishing point. So these are the important terms, and please try to remember this picture, this figure always in your mind. Always relate this figure with the given data whenever you are solving any problem on perspective drawing. Another important thing is, unlike orthographic projection system, the observer will always be standing at a finite distance from the picture plane. So this distance will be finite distance, and it will be given to you in the statement, in the problem statement. This distance of the observer from the picture plane will be mentioned, or if it is not mentioned, then there will be an empirical relation that we will discuss later that can be used to determine this finite distance. Lastly, the role of the picture plane in perspective drawing is to to obtain the projection of the perspective projection of the object. So whenever we say that we are going to make the perspective projection of an object, so that perspective projection will be obtained on this picture plane here. So that will be obtained on the picture plane. And one more very important point in the perspective projections is that there is no quadrant system as in case of orthographic projection. So please don't confuse the orthographic projection system with the perspective projection system. As I told you earlier, there is no quadrant system in this case. There is no quadrants in this case. So the observer will always be standing on one side, and the picture plane will be used to capture the projection, and the object in this case will always be placed on the rear side of the picture plane, that is on this side of the picture plane. That will always be the case. There will be a picture plane on one side of the picture plane. The observer will be standing at a certain distance that will be specified, finite distance, and the object will always be placed on the other side of the picture plane. So from the concept point of view, you can just understand that picture plane is an infinite size, transparent sheet, and the only purpose of picture plane is to capture the perspective projection of the given object. So it is an infinite sized vertical transparent sheet. Now all the terms that we discussed on this slide are again summed up on this slide: the ground plane, picture plane, horizontal plane, station point, ground line, vision axis, vanishing point, and horizon. Now just for your understanding, this slide basically shows the frame that you see here. This is the frame. This frame is basically, this rectangular frame here basically indicates the picture plane, and the object in this case is this scene that you see here, these rows of poles here and these artifacts in the middle. So this entire scene is on the other side of this rectangular frame, which is the picture plane, and the observer is standing on this side somewhere here at some finite distance. So this is how this scene will appear to this observer who is standing at some finite distance from the picture plane. Now in this case, the important thing to see is that all the poles which are vertical, they are parallel to each other. So these edges will never meet each other. You can also see these horizontal lines, they are also parallel to each other, so they will also never meet each other. However, the lines which are indicating the depth of the scene, that is these lines, when extended, these are non-parallel lines, so when extended, all these lines, even the tips of these poles, when extended, will finally merge at this point. So this point is the vanishing point in this case. So this is a drawing which is having only one vanishing point. Since all horizontal lines are horizontal, vertical lines are vertical, only the lines which are indicating the depth of the scene, they are non-parallel, so they are only yielding one vanishing point. So this is called the one vanishing point perspective system. So this slide shows the two factors that affect how the perspective view will look like. So the two factors which are responsible for the appearance of a perspective view are the distance between the observer and the object, and the second factor is the orientation of the object, how the object is placed with respect to the picture plane, the vertical plane we discussed in the last slide. So these are the two important factors that decide how the perspective projection will look like. Now, depending upon the relative positioning of the horizon line and the ground line, the perspective views can be classified into three types. Please keep this picture in mind that the ground line is the line which represents the plane, that is the ground plane passing through the feet of the observer, and the horizon line is representing the plane that is passing through the eye level of the observer. So in this case, the ground line is at the bottom side, and this object is placed is placed just on the ground, and this line here represents the eye level. So it means the eyes of the observer are at this level and the feet of the observer are at this level. So this is just showing the three different views of the same object. So in this case you can see this front face of the object is common in all the three views you can see, but in this view you can see the left face of the object, and you can also see the top face of the object. The reason being the eye level of the observer is at a higher level, and in this case, in the second case, in the middle case, you can see the no side face of the object is available, though you can see the front face, this face, and you can also see the top face. And so it means the observer is completely aligned with this object when this object is being viewed. In the third option, you can see the front face is again completely available. The top face is also available because of the height of the observer, and the right face of the object is available in this case because the observer is standing on slightly on the right side. Now this is a second case in which the eye level and the ground line, they are at the same level. So in this case you can see the same object, you can see the front face, you can see the left face, but the top face, like in this case the top face is not available because the eye level of the observer and the feet level, they are at the same position. Similarly, in this case you can see no sideways or no side faces are available. In this case you can see the front face is available, the right face is available, but the top face is not available. The third case is when the feet level is here, the horizon level is on the lower side, so it means the eye level is even below the feet level. So in this case you can see the front face, like in the other two options here and here you can see the left face, and in this case you will also see the bottom details of the object. In this case again you can see the front face, the bottom faces, no left or right faces, whereas in this case you can see the front face, you can see the right face, you can again see the bottom details. So in this case you can't see the top face, you can see the bottom faces. In this case you can't see the bottom or the top. In this case you will only be able to see the top face, no bottom details. So This type of perspective view is called the aerial view when the eye level is at a higher position as compared to the ground level. This is called the normal view, and this is called the worm's view. So in this case, the eye level is at a lower level as compared to the ground line. There is yet another type of classification of perspective views depending upon how many vanishing points are there. So depending upon the vanishing points, there can be three different types of perspective views: the 1 point perspective, the 2 point perspective, and the 3 point perspective or the oblique projection views. So in case of 1 point perspective, one vanishing point perspective views, you can see out of the three directions, the width, the height, and the depth, only one direction edges, they are non-parallel and they tend to meet at one distant point, which is called as the vanishing point, VP1 here in this case. So you can see the vertical lines are parallel, 1, 4, and 6, 7 are parallel. The horizontal lines are also parallel, but the lines along the depth direction are non-parallel. Similarly, in the second case, you can see only the vertical edges are parallel, but the lines along the depth and along the width direction, they are non-parallel. So in this case, there will be two vanishing points, as you can see, VP1, vanishing point 1, and vanishing point 2. Similarly, in case of three vanishing point perspectives as projection system, all the three direction edges, they are non-parallel to each other. So when projected, these edges along the three directions, they will yield three vanishing points, that is VP1, VP2, and VP3. So this is just an example of 1 point perspective view. In this case, we can see the vertical edges are parallel to each other. The horizontal edges here, they are also parallel to each other, but the edges which are along the depth direction of the street, they are non-parallel and they appear to meet at one particular point, that is a one vanishing point. So that's the one vanishing point here in this case. This is yet another example on 1 point perspective where this chair has got all the vertical and the horizontal edges parallel to each other, whereas the edges along this direction are non-parallel and they tend to meet at this point, which is the vanishing point for this view. Similarly, this is in this case also the horizontal and the vertical edges are parallel, whereas the edges along the depth direction, they tend to meet at this vanishing point. There's one difference between these two views, that in this case the left face of the chair is available because the observer is standing on slightly on the left side, so that the left face of the chair is available. In this case, the observer is standing right in alignment of this chair, so neither the left or the right, none of the two faces are available. However, in both the cases, the eye level of the observer is at a much higher level. So the top seat, the top face of this chair is available in both the views. So that indicates that the eye level of the observer is at much higher level. Then this is another example on 2 point perspective scene. So basically in this case we can see the vertical edges, these pillars, they are parallel to each other, whereas these edges are, when these edges are extended, then these edges are non-parallel to each other. So if we put the lines along these sides, then we can see that we will get one vanishing point somewhere on this side and the second vanishing point somewhere on this side, whereas the vertical lines, they are non-parallel. The same example of chair can also be seen in this case. We can see the chair has got all the vertical edges parallel, so there is no vanishing point along the vertical side. However, these edges on this side when extended will meet here, that is VP1. The edges on this side of the chair when extended will meet on this side, that is VP2. Then this is a third case when the scene has got three vanishing points. So in this case, even the vertical edges are non-parallel. So when extended, these vertical edges will also meet at one point. The edges along this direction, they are also non-parallel, and they will meet somewhere here on this side. The edges along the third direction, that is this direction, they are also non-parallel and they will meet somewhere on this side. So when we put these lines on top of this scene, then we can see the extended lines will yield one vanishing point on this side, one vanishing point on this side, and there will be one vanishing point on this side also. So the same can also be described by using the same example of chair. So in this case, you can see there are three vanishing points because the edges along the three directions, the width, height, and the depth, they are non-parallel, and they tend to meet at certain points, the three vanishing points. So this video was all about the brief discussion on what are perspective projections, what are the key terms that are used. Now we will have a look at two examples wherein we will be making use of AutoCAD to make the 1 point and 2 point perspective projections for simple objects. Thank you for watching the video.